Okay, so we are going to take a second and just look at different slopes, one, on an exponential graph and one on a linear. So if I'm looking at this linear graph, remember when we are finding slope, we have to count from exact points. So you can see we have 4 exact points here. If I look at the slope between these 2 points, right? My rise is 2 and my run is 1. So the slope here is 2 over 1. All right, well, let's look at the slope up here between these 2 points. My rise is 2, my run is 1. So this slope right here is also 2 over 1. All right, what we call this is a constant rate of change. Okay, and what that means is in a linear function, this is very important, this is only in linear. In a linear function, anywhere on the line is going to have the same slope. Even if I want to look at these middle 2 dots, right, I'm going up 2 over 1. The rate of change stays constant, right? It doesn't change. The slope is 2 the whole time. Now, that's not the case with the exponential function, all right? So I'm going to go ahead and I'm going to do the same thing. I'm going to pick out some exact points here, okay? And we're going to count the slope. So if I'm looking at the slope between these 2 points, I'm going to go up 1 over 1, all right? So that slope is 1 over 1. All right, well, let me look at the slope between these 2 points here, okay? I'm going to go up 1, 2, 3, 4, and over 1. So this slope is 4 over 1. All right, well, and what about in here between these 2 points? Up 2 over 1. All right, so now that slope right there is 2 over 1. So basically what we see is that we have a changing rate of change. All right, it is not constant. All right, and how we can tie that to the beginning of this lesson is, when I start here with a slope of 1, my slope is not very steep, right? Well, as I go up the curve, the slope goes from 1 to 2, gets a little steeper. Then it goes from 2 to 4, gets even steeper. And you guys can just imagine if we went all the way up this slope, and you can see there's a doubling pattern here, right? 1 times 2 is 2, 2 times 2 is 4. So we can say that between the next 2 exact points, the slope is probably going to be 8, which is much, much steeper. All right, so we go from less steep to more steep to more steep to more steep. Because the rate of change is changing, it's creating that curve, right? Where on the linear side, right, the slope stayed 2 the whole time, which is why it stays in a straight line, right? Anywhere on that graph, the slope is going to be 2. It's a straight line. With the exponential function, since the slope is changing, we get that curve.